So if we start from MATLAB, this is the main window of MATLAB. As I mentioned, your objective is just to click on the MATLAB Simulink. This is the icon. You're gonna find lots of panels here. You can start with the first one, which is the blank model, because we would like to build a model of RLC circuit. This is what I'm gonna do through this video or this lecture. So clicking on this one, this window will be open. This is gonna be like your workspace, like anything. You're gonna build the model over this white area. But this model, definitely you have to bring some blocks. This is how the MATLAB Simulink is already working. Like you're gonna bring some blocks and you're gonna arrange these blocks together to build the model. Then once you press on run, there should be run. It's gonna show up here. It will be activated. Now it is deactivated, but it will be activated once you set up the model. Once you run, you're gonna end up with results. The good thing of the MATLAB Simulink that it can give you the results as long as it is typical the same way if you decided to solve the circuit equation analytically. Like what we're practicing doing through the course is to do analysis for electrical circuits by modeling the given electrical circuit into some differential equations. Then we can solve these differential equations to end up with the current as a function of time or the voltage over a certain element as the typical things that we practiced before through this class. Okay, so if we considered an example of RLC circuit, like this conventional RLC circuit, like let's say I'm just gonna bring one example here. As I mentioned, to do it we have to bring some blocks that we can arrange them to build this RLC circuit. So definitely some of these blocks we should have resistance, we should have capacitance, we should have inductance, right? We should have these three electrical elements. So to bring or to recall any one of these blocks, you have to go to the library. The library, you're gonna find this icon here. If you press on it, you're gonna end up with this list. I highly recommend, because the list is very long list that includes so many blocks. Each one of these things are blocks. To include a block, simply you're just gonna drag it. You're just gonna drag this one and it will be included in the workspace. Okay? And then you can go back again and bring one more blocks and so on. So this is, for example, like this blocks as written here, it is AC current source. We discussed before in this course that the sources, it would be voltage source, it would be current source, right? So this is AC, which is alternating current source. It means that this current source, it is a function of time. This is a block. In case that you already given an electrical circuit with a current source, you have to use this block, okay? Also, there are lots of other blocks. How about, for example, the resistance and the capacitance and so on? So we need resistor and capacitor and inductor. So we can type here RLC, and instead of looking and skimming over all of these long lists, you can directly search for the electrical element that you are seeking. Like I'm just gonna type here RLC and press enter. If you did this, you're gonna end up with so many blocks here. The thing that we need, the best way, the easiest way to incorporate or include resistor, capacitor, or inductor is using series RLC branch. Use this block. If you drag it, it will be included here. Then he's gonna ask us regarding how much is the resistance in terms of ohm, the capacitance, the inductance of this electrical element. There is no need even to type anything. You can double click on it. You're gonna end up with this window. This window, for example, we may have, so as you can see, by default, these three electrical, this block include the three elements together: resistor, inductor, and capacitor. And these are in series, so that's why we have the name series RLC branch. But how about if I just need resistor, only resistor? So you'd have two options. One of the options is just to put R, which is the resistance, with a value, and put the inductance and the capacitance zeros. Or simply you can go to this checklist and choose R. I needed R only. or you needed RL or RC or LC, it's up to you. So I needed R only. So you're gonna end up with just resistance. Then it's gonna ask you how much is the resistance value. You're just gonna type like 10 ohms. And okay, so we got resistance. How we can include a capacitor? A capacitor, so we're gonna have a copy. Instead of, you can go back again and drag one more block, or you can directly have a copy of this block. How I can have a copy of this block? You're gonna press Ctrl and drag it. If you press Ctrl and drag it, you're gonna end up with another block, a copy of it. Then you can double click on it and change. I needed capacitance, C, and set the value for the capacitor in terms of farad. We mentioned before that usually the capacitor should be in the microfarad scale. So let us assume, for example, like 15 microfarad. So 15 microfarad is going to be 15 E negative 6. And press OK. So this is going to give us a capacitance with this value. If you double click on the words here, you can, this text down here, you can type C, for example, it would give a name to this capacitance. What's wrong? You can double click, it should be working, yes. So just click on this one and type C, for example. It stands for, like, this is the capacitance, and you're gonna type here R, stands for the resistance, I mean. Then you can have another copy, Control and drag, you're gonna end up with another copy, and instead of having L, R, it should be L. Inductance, and I'm gonna use inductance, for example, like 5 henries, and press OK. And you can change this into L. So these are the three elements of a fundamental RLC electrical circuit. So let us remove this source for now. So we do have the three elements. Now we can arrange them. We can arrange these elements in any other way. It's up to you how you're gonna arrange these elements. So for example, I'm just gonna put this electrical element here, and I'm just to give a rotation to block. To give a rotation to the block, you're gonna press Ctrl R. It will be rotated in this way. So I'm just gonna align this one. Then you can connect them. This resistor to the inductors and the inductor to the capacitor. As we mentioned before, for the RLC circuit, it doesn't matter which one comes first. Any order, it doesn't matter. So this is the fundamental thing of this electrical circuit. Then we need a source. We need a voltage source, right? So voltage source, and we needed AC voltage source. It means that it is alternating voltage source. So you can type here in the search AC voltage source. Very simple, and press enter. So it's gonna give you a list here, AC voltage source. But there is another AC voltage source. Don't use the one with the blue mark or the blue color. Use the black one, this one. This is the one that we're gonna use in something related to this MatLab Simulink. It has other applications. But for this case, make sure that you drag the black one, which is AC voltage source, and this is what we're gonna use it here. So this AC voltage source, it should be in the sinusoidal form. As you can read, ideal, it is ideal, sinusoidal, AC voltage source. So for the sinusoidal form, as we discussed in the chapter 5, any sinusoidal form, it should have a big value, which is the amplitude value, the maximum value. So how much is the maximum value of this volt? It is, by default, it gives me 100 voltage. Let us assume, for example, it is 50 voltage. This is the big value. And we do have the frequency. If you remember the sinusoidal form, it should be in the form as 50 cosine omega t plus theta. Omega, which is the frequency, how much it is, you can put it, for example, here it is given in hertz. But omega, in the equation that we used to cover in chapter 5, it was given in radian per second. So you have to consider the unit difference. Here the hertz, he defined it in terms of hertz. The frequency, he defined it in terms of hertz, not radian per second. So if you already given a problem, and omega was given a radian per second, you have to convert it first into hertz, and you're gonna use it in hertz here. So let's say like it is 70 hertz. Then the phase angle, this is the angle, it should be in degree, like 30 degrees, 90 degrees, 60 degrees, it doesn't matter. You're gonna plug the angle here as a phase angle as it is already given. Make sense? Then you're gonna press OK. So we define everything regarding this voltage source. Then your objective is just to connect it to the resistor, and if we connect it till the end, to the end, we already got the electrical circuit. So this is the fundamental shape of the classical RLC circuit. Make sense? If you would like to zoom in, you can zoom in by this the scroll wheel of your mouse, zoom in and out, or even if you would like to see like zoom all, so you can see this circuit filling into this workspace area, you can press space. If you clicked on the space, this is gonna automatically gonna fill this electrical element or make this electrical circuit filling within the workspace. Okay. So now if we run, as you can see, run is already activated. If we run, forget about the error. Even though if there is no error, what is the error again? Yeah, I see. Forget about this error. Even if we run, we didn't provide anything to extract or to represent. For example, this is how MATLAB Simulink is working. So, are we interested in measuring voltage or are we interested in measuring current? Usually when we do analysis for any electrical circuit for given problem, you will be required to find a voltage over a specific element, find the current over a specific element, right? So for example, how about if we are interested in finding the current within this electrical circuit, how much it is? So we should include a block to measure a current. This block is commonly known in electricity, by electrical engineering as a mirror. A mirror, which is something that measures the current. It is a current detector. It is like a small device that detects the current over any branch. This is like electrical wire. If we put a mirror here, it's gonna give us the current over this branch. If we are interested in the current over this branch, we can find it, and so on. Make sense? So let me, for example, add one more parallel branch here. How about if I'm just gonna take a copy of this resistance and I'm just gonna rotate it vertical, and then I'm gonna connect this resistance to this branch. So this electrical circuit is a two-loop electrical circuit, right? So at this node, how much is the current? Over this branch, how much is the current? Over this branch, how much is the current? As we used to say that we do have the total current coming from the source, and it's gonna be split into I1 and I2. So how much is I1 and I2? We can figure it out using the MATLAB Simulink. How we have to use ammeters to detect the currents over these three branches. So how we can do it? You're gonna recall here, you're gonna search in this library, you're gonna search for current measure. Current measure. I want to measure a current. So it's gonna give you this measure, this current measurement, this device. This is the ammeter that I'm talking about. Then you're gonna drag this block here, and then if I put it here, if I connected this end to this end in this way, just like you can even adjust this thing in this way. You got my point? So this ammeter right now, if I run the electrical circuit and let the current to pass through, this ammeter is gonna measure the value. This is the detector. It's gonna measure the current value over this branch. Make sense? Then what if you have another copy of this? So I can even give a name. I can give a name to this one before the copy. I can give a name to this current measure as IS. Like this stands for the total current, which is the current over the voltage, right? And then I can have a copy of this one. So it's gonna be like IS1. No, I need it like I1 or I2 or I1. Okay, then you're gonna connect this I over this branch. So I would like to detect the current over this branch. Make sure that it is connected here. Okay, so this second ammeter, this gives the current but over the second branch, this vertical branch, which is I1. Then if you have another copy of this ammeter, we can put it here anyway. And then you're gonna connect it directly to this branch. So this third ammeter, this one detects I2. Make sense? So now we can detect the three currents over the electrical circuit. So these current measures, these are the ammeter to detect the currents over any branch. Very simple. Make sense? Then what? How about if we are interested in finding the voltage over all of these different elements? How about how much is the volt over R? How much is the volt over R1? R1 we didn't specify its value. Let us assume that it is like 15 ohms. So, and let us put this one like R1 and this is R2. It gives me error because I already using R1, so I can name this one like R, just R. So, how we can detect the voltage or measure the voltage over the capacitor, the inductor, the resistance, and so on at any branch. So the difference between the current and the voltage should be detected by 2 points. Like you should have, for example, to measure a voltage, we have to detect the energy before and after the resistor to know how much of voltage across the resistor. The voltage is voltage drop or voltage reduction or change over the electrical element. So it is different than the current. The current we detect from a branch. So we do have only one input, one signal, one link. But for the voltage measure, you're gonna go back here and type, instead of current measure, I'm just gonna type voltage measure. So it's gonna give us the block to measure, which is commonly known as voltmeter. This is the voltmeter that measures the volt. So we're gonna include this block here. This detects a voltage. As you can see, what is the difference between the current measure and the voltage measure? The current takes only one input, but the voltage takes two inputs. Why? Because we have to detect the drop in the pressure, the energy, or the drop in the voltage before and after the electrical element. So that's why we do have two inputs. Make sense? So let us have this one. Let us give a name like VR. Like this is gonna be the voltmeter that is gonna measure the VR, which is the voltage over the resistor. Then what? Your objective is just to connect one side to one end of the resistor. I can put this one here, and the other end is gonna be connected to the other end of the resistor. Make sense? Like as you can see, this like one branch to one end and the second branch to the other end. And you have to keep eye over the positive and the negative. If you switch this one, it means that you already, if you remember when we applied the Kirchhoff voltage law, we said that the voltage over R is output. If you switch this phases or these branches, positive and negative, you already switching from dealing with this R as input or output. Like in the loop Kirchhoff equation or the Kirchhoff voltage law, we do have the VR. We can put it positive VR or negative VR. If you would like to switch between positive and negative, switch these branches. Make sense? But if you make the negative after and the positive before, this is gonna be dealing with this R like it is output. Then I can have a copy of this voltmeter and put it here, for example, to measure the voltage drop over this resistor in this way. Then, so this is gonna be like VR2. Then I can have another copy to detect the voltage over the capacitance. Then I can have another copy to detect the voltage but over the inductance. in this way. Make sense? So we already added all of these blocks. So now we do have the voltmeters, we do have the ammeters to detect the voltage and the current over different branches and over different electrical elements of this electrical circuit. Now if we run, remember that we still gonna get an error. Okay, forget about the error. Assume that there is no error here. We didn't see anything. How much is the voltage? How much is the current? How much is these data? We have nuclei, how much they are. We have to represent them. We have to show them. Okay, we have to represent them and we have to show their values and how they are changing over time. Because as you can see, this is AC voltage. It means that this VR, this VR2, this VC, which is the voltage over the capacitance, the voltage over the inductance, these voltage values will not be constant value, will be varying over time. So it should be like functions over time. The same thing for the current, it will be functions over time. So to present a graph of the variation of the current or the voltage over any branch or over any electrical element or any output, you have to use a scope. The scope it is, if you're gonna go to here, this one, and just type scope. Or if it is not shown, you can find it directly on Simulink sources. Simulink sources, I'm sorry, Simulink commonly used blocks. You're gonna find it in commonly used blocks, scope, this one. This is scope, this is like a window. If you double click on it, it's gonna give you a figure. So we, as you can see, there is nothing is drawn here because this scope, it should be connected to one of these ammeters or voltmeters to detect the volt or to draw. This is like the monitor. This is like the screen of your laptop or your computer. Like we do have something, the value is already here. Now it is saved inside VC, VL, I1 and I2, IS, but we have to show, represent this one over a graph. So I have to use a scope. Make sense? So I'm gonna use a scope for each one of these parameters, for each individual one. So, for example, if I am interested in representing this voltage, so your objective is just to connect it in this way. And you can give it a name if you wish, or just leave it blank, it's up to you. Make sense? How about the scope for this one? I can put another scope for this voltage. I'm just gonna connect it to this voltage here. And another scope for this voltage. Another scope for this voltage. So these four scopes detect or will represent the voltage over all of these electrical elements. Make sense? How about if you're interested in finding, in representing the current IS, I1 and I2, how they are changing over time, so you need a scope for them. So I'm gonna add here some more scopes, like one more for this current, I2, and this is scope for I1, and you can name them. And I'm gonna add one more scope for IS. Make sense? What again? No, because I know the voltage source. It is in many of the cases gonna be given. Yeah, for the output. يعني انت بتحط السكوب للحاجات اللي انت عايز تظهرها. You put the scope only for the things that you would like to represent. Okay, so assuming that the voltage source is already given and we are interested in finding the current over these branches and the voltages over the other branches, other elements. Make sense? Something, okay, so there is issue here. Okay, anyway, there would be something, we would end up with some issues like regarding this branch, because as you can see the current it is output, right, input, and we do have output of the current here, okay? But here we are interested in just showing the input. This is gonna be like one input, and we just interested in finding the current over this branch. So I'm just gonna check if it's gonna work or not in this way. But anyway, this is by default how it's gonna work. We just assigned scopes to the different currents and voltages over this electrical circuit. Now, if we run the code or we run this block, it should be the voltage and the current should be shown here. But we're still gonna get an error, and I'm gonna let you know why. If you run the code, we're still getting an error. The main reason is that we don't have here, like is related. If you just click on it, it's gonna give you this is the error is related to this one, and it means that this battery is not working. Battery, it need like a sort like it you have to add another block here, which is known as like power generator. This is just to indicate that there should be electrical circuit that is going to be used for it should be powered, kind of. So it means that there is still missing. If you received this error, this definitely in many of the cases gonna be cause that you didn't include a power generator. So if you just type MUX, just MUX, I'm sorry, the power, no, the power GU, for example, or GUI. Come on. Okay, let me check how what is its name. So let me run the code again. It should be okay. Power GUI. If you just copy this one, which is power GUI, but there is no space. So this one, this power GUI, you're just gonna drag this one and put it here. It won't gonna be connected. This is like, you know, like a button that informs that this is like power, something related to power. Simulink is one of the features in the MATLAB Simulink. So your objective is just to run the electrical circuit. You have to include this block first, then you're gonna run. So now we are in a good shape, and once you hear this hit, it means that it is done. Now if you clicked over any one of these scopes, you're gonna end up with the figures, results. But as you can see, the voltage over this capacitor, it is varying, and it is barely seen like it is a single block, but originally it should be wave. But since we're already representing over 10 seconds period, this is the period over this graph. This is the time axis of this graph. So if we shorten this period into just 1 second, and we run again, and double click, you're gonna see the wave, and you can shorten further even. So this is how the voltage over the capacitor is changing over time as a sine wave or sinusoidal wave. Also, this is the voltage over the inductor, and this is the voltage over the resistor, this resistor, and this is the voltage over the other resistor. And this is the current. As you can see, the current is zero. It's giving me zeros. It is zero over these 3 ammeters. Why? Because the other side of the mirror is not connected. So let us connect this one here. Like this is the input and the output. And connect the this one here. And connect the other side here as well. Okay, and let us run again. Let's see if we're gonna get. Okay. So we're still getting zeros. Okay, I got it. So I'm just gonna remove this thing, these scopes, and the current. So, but it works for the voltage. So the ammeters or the current measures. seems that they should be connected in series over the branch, that you already detecting its current. Like for example, let us work over this one. So let me see if I can move. Okay. So let us choose this one, but it should be connected. Okay, do you see this branch here? This thing, you're just gonna delete this one and close the loop through this current, like you already putting this one as in parallel, in between. Understand? So it should be in series, I'm sorry, it should be in series with this R and the branch. In this way. And we have to do the same for the others. But let us examine it for this one. Examine this one first. So it means that this current is going to detect the current, this ammeter is going to detect the current over this branch. Then if we have added a scope here, just add a scope. Come on. If we added a scope to this current, it should be working and connected, and then run. I'm just trying one current now. And double click, we already got the current. So the key idea that this ammeter, it should be in parallel, in series with over the branch. Like for example, if you are interested in measuring the current over this branch, this small branch here, so I'm gonna add this or this one. Let us work over this branch, this one. So your objective is just to remove this branch first, then you just connect one end and the other end here. You got it? So it should be like kind of confined. You already putting this ammeter in parallel, in series with this resistance. Now you can find a scope to this one and connect it. So you can, it is advised like before you start drawing and putting these things, you put like a plan over like a white sheet and try to arrange these boxes so it can be clearly seen. The same thing for the other branch, which should be this one. Okay, if we try to connect it here and connect the other end here, then we can, I believe that we can remove this branch in the middle. So it has one end and the other end, then we can have a scope. Then if you run, so we already got here current, which is I2. As you can see, the maximum value is 0.015, and the current here is 2, which is the current over the maximum value of the current over this, which is over this vertical branch, and we do have the IS, which is this total current, which is 2.0.15, I mean. Okay? So this is simply how we can represent the electrical elements or find the voltage and the current over branches and a specific electrical element. But how about, for example, if you would like to present multiple results at once? Like, for example, how about if you are interested in finding and representing the voltage VC and VL and VR2 in comparison to each other? So we can do it, but in this case, we have to bring a block that is named MUX. You're just gonna type MUX. This is like a junction or like which is this one. You can have this MUX and put it here. Then it's gonna ask you about the number of inputs. Number of inputs, it means that how many outputs that you would like to represent. For example, let us represent the VC, the VL, the VR2, the VR1, the VR, all of these voltages, let us represent them over one graph. So it means that we need 4 inputs. So I'm gonna type 4 and press enter. So you're gonna find like 4 things here, right? Then your objective is just to connect this one to this one. So this is one branch. This is one input, VC. Also, I need VR2. I need VL. You're just gonna connect to the VL branch. Make sure that it is connected to the VL. And I need VR, which is this one. As you can see, I connected to the output of the VR, the output of the voltmeter itself. Okay? Then this output, it will be connected to one scope. It will be connected to only one scope in this way. Okay? Then if we run and double click, we're gonna end up with one figure representing all the voltages of the over the 4 elements, all of them together. Make sense? So this is simply how we can use, and if you press space, it's gonna zoom in a little bit. So this is how we can use the MATLAB Simulink for doing analysis for RLC circuit or whatever the type of the circuit. Your objective is just to build the circuit, both these ammeters and voltmeters and the scopes, and so you're gonna see the results as you in the way that you want. For example, if I change the source, if you change any element like this L, I can change its value. So you're gonna and run again, you're gonna end up with different results and so on. Like for example, if I change this voltage, let's say like the big value, I'm just gonna assume that I do have 0 frequency. It means that there is no wave. Okay, and the phase angle is also 0. Okay, and so it means that it should be like DC voltage. It is like kind of DC voltage. Then if you run, we're gonna end up with results. So as you can see, for DC voltage, we do have like kind of decay. And these waves, some of the waves already decaying in this way, like some of the voltages. This is gonna give us the voltage and so on. Even you can change the source. Here we are using AC voltage source. You can use a current source. You can use a current source by typing here current source. Current source or AC current source. AC current source, which is this one. I can add here one more source even. I can add over any branch another source. Or I can replace this source with a current source. This way. And the current source is going to be also in the sinusoidal wave. As a sinusoidal, this is its peak value. This is its frequency or whatever. I can put it 0 and the phase 0 and its big value as 10 amperes. This is the current source. Then you're gonna run, you're gonna end up with some results in this way. Shows how this voltage or these currents, even the currents here, the current over this branch is gonna be decaying, the current over this branch is gonna be 0, and the current of this branch is gonna be decaying in this way. Okay, so this is simply how we can do analysis for electrical circuit, the things that we already covered in this course and more, using the MATLAB Simulink. So for your project, your objective is to do a similar thing. Make sense?